Foundations of Amateur Radio. Over the past year and a half, I've been working on a secret project. Today, I'd like to share what I've been up to. To set the scene, I'm not doing this on my own. A fellow co-conspirator is Randall Victor Kilo 6 Whiskey Romeo, who became a radio amateur about 20 months ago. Randall has a long association with the Engineering Development Array and the Murchison Wide Field Array, two of several radio telescopes that are built on one of the few radio quiet areas in the world and located near the future home of the Square Kilometre Array, the SKA. One day Randall and I started talking, as you do. New amateur, new topics, interesting new fields and ideas. We hit on the idea that radio astronomy telescopes are able to receive 2-metre signals. This started a discussion about using a radio telescope to receive a moon-bound signal. So the idea was born. Can we create a 5-watt signal, bounce it off the moon, and have it heard by a radio telescope? Randall and I have been working on that on and off since our first discussion. Let me start by pointing out that we've not managed this yet, but we think it's a project worth doing, to forge cross-skill exploration by various different groups. I have a strong background in IT and a few years as a radio amateur. Randall brings with him a wealth of radio astronomy engineering expertise, not to mention signal processing, communications, and a myriad other skills. We started to do this on the quiet. Why talk about something that hasn't happened, might never happen, could be done by someone else who'd claim the glory before we did, and so on. I've come to the realization that while those things all hold true, this is a non-trivial project to achieve, and anyone who puts in the work and gets there is welcome to claim the glory. So in the 20 months gone by, while both working full-time, we've done lots of things. Let's set the parameters. When we first started, both of us were holders of an amateur foundation license. This means hand-keyed Morse, 10 watts and band restrictions. Because I'm me, I decided that the difference between 10 watt and 5 watt wasn't significant enough to make or break this, so we went with 5 watts QRP. Our license precludes the use of WSJT modes invented by another radio astronomer, Joe Kilo 1 JT, so the signal had to be something else. We settled on a manual slow Morse signal. We're using a radio telescope at one end, so it had to be on 144 MHz. Those decisions made, our first project was to attempt to calculate if we could actually achieve this. Conventional wisdom says no, but our ongoing calculations, revised several times since our original effort, show that we're right at the edge of what is possible. We then started the process of determining if the radio telescope could actually hear moon-bounce radio signals. We have a limited field of view, roughly 20 degrees around vertical, so the moon has to essentially be above the telescope. The galactic center is a very noisy place from a radio perspective, so it has to be at least 20 degrees away from the moon. Similarly, the sun, also very noisy, needs to be 20 degrees away from the moon. That started a process of me learning Python so I could use AstroPy to create a table with observation times that matched those criteria. I'm still working on that. Having been a programmer for 35 or so years, I'm not a fan. We did some manual calculations to do some test runs and had 2 amateurs send a signal to the moon, which for several reasons we were not able to detect. Traditional Earth-Moon-Earth EME communications benefit from ground gain, something like 3 to 5 dB of gain based on the path essentially ducting across the Earth, but that requires the moon to be near the horizon, so not relevant for our project, since the moon needs to be overhead. Of course, it might mean that I need to travel halfway across the globe so I can get the gain, but that's another project for another day. We get some effective gain from having a very stable signal. You might recall I purchased a high-stability compensated crystal module, a TCXO, for my radio a while back. This project is why I did that. Another thing I purchased at the time is mechanical filters, which also provide a little effective gain. We started the process of acquiring some high-gain 144 MHz Yagi antennas, but through some miscommunication with the amateur who was selling them at a really nice price, we missed out and haven't yet bit the bullet on another set. Initially, when Randall and I started this, we were working on it on our own. We tried to learn as much as we could and test the waters ourselves. We've been at it now for a while, and it's become apparent that this is going to be something that is likely to involve several other amateurs. Some have already been helping. Alan, Keith, Alec, Lee and Marcin all contributed time and material. No doubt this list will grow as the project continues. At the moment I'm still trying to write code to create a calendar of dates that will suit the radio telescope with the restrictions we have in relation to the Moon, Sun and Galactic Centre, so we can actually prove that the telescope can hear an amateur radio signal. We'll need to source some high-gain antennas, likely more than 2. Once we've done a one-way test, that is, me sending and the radio telescope hearing, we'd like to do the same but between 2 QRP stations. No doubt the road ahead is paved with spikes, potholes and roadblocks, but as adventures go, this one has been sustaining me for nearly 2 years, and so far it's showing no signs of abating. I'm Onno, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.